Okay, so I am sure I'm audible sufficiently today. Right, so today we are going to discuss a few internals or maybe few basic details about the three types of relevance, and we'll try to understand what could be the possible new dimension we can have, right? So because it is, again, I'm saying it is an open research area, so you can always propose a new set of parameters. That's what you can do, right? So whenever we are planning to propose or design or create new type of relevance measures, it is important to understood the basic essence and the place where these relevance measures can be plugged into the system, right? So in the previous class we have briefly outlined actually the possible three types of such dimensions, we can say. All right, so that's what we have talked about, and then we have taken this retrieval model. So retrieval model we will be discussing naturally in the upcoming classes when both this ranking and matching will be explained sufficiently. So today our focus is to understand these three dimensions of relevance, right? Because these three dimensions of relevance can be plugged into a single system at a time, right? Because I mean, you can have at least one relevance measure, that is the requirement. You can have second also, you can have all three also, right? So it depends on the capability of your system, that how many algorithms or how many measures you have planned. So as many as relevance measures are planned into the system will be more inclined or more user centric, right? But you should be carefully planning your algorithm or planning a measure or maybe formula for each relevance type, right? So typically that's what we have taken. We have said, okay, we have three possible dimensions or three possible types, broadly you can say, of relevance measures, which can be plugged or designed into a information system or maybe in the search system, right? Because whenever we are having the user presence, whenever we feel user will be going to consume the information, you need to provide some sort of relevance estimation, right? So we have taken it, and broadly it is assumed that all the implicit nature of relevance matrices or relevance measures are directly computed by some algorithm. So that's why it is called implicit. And whenever we say what about explicit and pseudo, these are considered as a kind of feedback. So because it is coming from or it is derived from some sort of external behavior of user or maybe some sort of external behavior of system, right? Like for explicit kind of relevance, we assume that it is coming from the user, directly coming from the user interest. So user will be naturally pushing a query, and after getting some results, user will be again pushing or interacting with the system. So these external interactions will be captured as explicit relevance, explicit interest of user on the information. So these things will be captured as a feedback, and it will be utilized for the generation of relevance estimation for the ranking purpose. There is this third type of relevance, which is called pseudo relevance. It is considered as a you can say the information system's feedback to the retrieval process or to the relevance estimation process, right? So because in this whole scenario we are assuming there are two bodies which are interacting. One is user, two entities. User is first entity and your search system is a second entity. So you can utilize the presence of both entities, right? So that's why we are having explicit relevance estimation from the user's interaction and pseudo relevance from the system interactions or system behavior in the search process, right? So there are various research efforts or research works has been done for the third part of relevance. There are various recent developments have been proposed that the system, whatever results system has generated to the user, it can be utilized, right? It can be utilized to get the next set of results. So there it is come that you can say it is the rule of recommendation and predictions, all those things. So all the previously fetched results can be utilized to recommend the new set of results, something like that. So so you can always propose a new type of. So within implicit, we are saying, okay, we could have 3 possible subtypes. In the explicit, you can have n number of ways of arranging or capturing the user's presence. In the recent developments, there is a software by Google itself. They are trying to capture the user's eye movement during the search process. They have created a system which is, so while you are searching some information on the Google search system, they are trying to capture your eye movement, right? So based on that, they are assuming that this eye movement basically indicates some sort of user's relevance. So you can always have a new mechanism to capture the explicit relevance, right? Because we are assuming that bookmarking, tagging, accessing, these are basically some sort of fundamental ways of user interaction on the results, which are externally applied into the system, right? So we can have always new mechanism to capture the user relevance. You can provide some sort of option to users and ask user to provide some sort of feedback, provide some sort of action on the results. So that is up to you again. So you can utilize the presence of user interface for that. So that's why it is very important to have a very interesting GUI, a very interesting or interactive user interface for the user on the top of any such system, right? Because it helps you to capture the user's interactions, user interest on the results, right? So now if we discuss a little into the details about these 3 types of implicit relevance. So the broad thing you can say, the implicit relevance measures are the relevance measures which are often computed by, or maybe which are often computed based on some sort of inputs, some sort of pre-computed values, either on the document set or maybe in the user query. So you can say it is the most fundamental way of computing the relevance for the ranking process, for the ranking component, right? So you must have heard about various keyword based statistical values. So like we are often using, so whenever we have set up documents, whenever we have a query, the basic way of computing the relevance is to arrange the documents based on the frequency of user keywords within each document. That is the basic, or maybe you can say the naive way of doing the ranking process, right? So if you have 10 documents and if user has posted a query of 2 keywords, you can simply perform some kind of pre-processing and tries to identify the frequency of user query term into each document, and then you can arrange these 10 documents in order based on the frequency of that user query term. That is the most fundamental way of doing it. So similarly, you can derive different statistical values naturally. So these values, these measures or these scores must be computed either in the terms of user query within the document naturally, or maybe you can generate some sort of these informations from the documents itself, right? So we will be talking about, so you can say there is a fundamental rule that whenever we are trying to design an implicit relevance measure for our system, you should be based on this comparison or relevance measures score will be based on the document corpus or maybe the user query. So you have 2 inputs to plan our implicit relevance measure. So we will be discussing upon these measures, right? So some of the example we will be taking. So particularly if you go into the AR, which is called algorithmic relevance. So algorithmic relevance says you should be having some relevance measure, and these measures should be estimated by comparative effectiveness of logical and statistical similarity of the features, right? So features means that's what one feature is number of occurrence of query term within the document. So that's what you can say. So you will be having an algorithm where user query term will be compared, and this query term occurrence will be used to estimate or to position a document in the relevance score. That's what you can hear. So the basic crude way, a fundamental way of doing the algorithmic relevance is to count or estimate the number of occurrences of keyword into the within the documents or within the information object. Then you can estimate a relevance. Then you can arrange all these retrieved documents. That's one way. Second way of doing the implicit relevance could be it could be the type of pertinent relevance, and it is measured. So whenever you are planning to design a pertinent relevance, it is basically having this comparison between two statistical values by measuring the term of a relation between the state of knowledge and cognitive information needs of user. So this implies, so whenever we are planning to design a PR relevance measure, you should be basically having this statistical value of users understanding on the information object. So basically, one typical example of it is if you are aware that in the user query we are having two keywords, and if we swap the position of query keyword, it will affect the the relevance or these arrangements of document in the first page. So if this is one typical example, so if you are aware about the position of keywords in a query, if user is somehow familiar that okay, if I place term 1 then term 2, or term 2 first then term 1 first second, so if we swap the position, it will affect the results of list of results in the very first page. So this kind of arrangements you can make. So in the pertinent relevance, it is observed that you can have a relevance measure where which captures the user's familiarity, user's awareness about the information objects, and his action. So how he can apply this interest. So this positioning of query word in query term in query, it is one of the type of it. So we will be taking it in example. So one of the recent advancements has been observed in these PR based measures are query term proximity measures, right? So we will be talking about this. Then last type of implicit relevance is called situational. So it is little complex to measure, and it is little complex to model it, right? So you can always have a formula or model or approach for AR based algorithm relevance measures and PR based. But when it comes to SR, which is called situational relevance, it is little difficult because it says it should be measured in the terms of relation between the perceived situation, task or problem at hand and usefulness of information objects. So because it is little difficult to capture the user's perception about the situation. Naturally, a such task is given to user, and user has applied a query, and you can have some sort of AR based relevance measures, some sort of PR based relevance measures, but it is very difficult to capture the user behaviors, user perception about the situation task. So there are very limited type of formulation, type of measures proposed under this category, and it is a complex situation because it is capturing the perception area of a such user. So there are very few measures which has been proposed under this category, which can be utilized, which can be modeled into the model to be into an algorithm, right? So so let's go into these three types of measures by having some examples. So if you see in the implicit relevance measures, these are the typical you can say the matrices or maybe the formulas or maybe the parameters which can be adapted and which are widely available also. So AR based, most of the AR based approaches are like you can have term frequency measure, you can have IDF also, inverse document frequency, then you can have the combination of TF and IDF, right? So you can always have this combination TF-IDF, you can utilize the document length also. So if your query is retrieving 10 documents or 20 documents, you can always estimate the length of document and arrange them into some preferred list, right? So likewise, you can always plan. So here you can see the term frequency means the frequency of the query term actually. Here also you can see the inverse document frequency based on the user's query term. It is always with respect to user query. So here we are utilizing the statistical values computed on the document's text with respect to user query, right? Similarly, if you talk about PR, pertinent, so pertinent relevance is basically is some sort of situational position of user query terms in user thought process. It is one of its kind. So if you take query term proximity value statistics, so to estimate the relevance, so this could be like, so recently we have proposed for these 4 measures. So it could be like query term span, query term mean cover, query term max distance, query term mean cover. So these are the proposed measures. So in the very first measure, we are saying uh, this position of user query within the document. Because if you assume that any document is basically a set of text, it is having text document, text articles. So the position of, so suppose in a user query we are having 2 terms. So the position of these user query terms within the document will also have some effect, right? So one measure we have proposed as a span. Second measure we have proposed a mean cover. So we have computed the values for all these 4 measures for one single user query, and we have arranged these 4 measures, span, mean cover, max distance, mean cover, to estimate the PR based relevance. And we have utilized these four sets of measures to estimate the implicit relevance, right? So similarly, you can also propose a new set of measures to estimate the AR or maybe PR. So most of the people are working, because this AR based measures are already proposed in a sufficient scale. There are there is very limited space to work upon these kind of relevance measures. So most of the researchers are working upon the second set of implicit relevance measures, which are falling into the PR, right? Pertinent relevance, to capture the PR aspect of the search process, because SR is again a difficult portion. From the user profile information, right? So we assume that whenever there is a system, there is a user, you can always maintain a user profile, maybe externally or maybe internally, right? So when we maintain user's profile, you can always take out the user's information, his interest, his category, all these things, and you can always extract his search informations, and you can always maintain the list of previous results he has seen or he has explored. So after utilizing these user profile informations, you can derive some sort of relevance, or you can generate some sort of relevance estimation, right? So these are basically basic or fundamental types of statistics we can have to estimate the implicit relevance during a search or during a relevance ranking process. Then if you take one typical example, one typical model we have placed, so what we have done, we have created a reference model for you. So basically, if you can see here, this is one conceptual model we have proposed. So in this case, you can see we have given a user query on the top. User query is having T1 and T2. And these T1 and T2 query terms will be applied on the UI user interface. And based on these T1 and T2, we have basically extracted the objects, right? So to extract the objects, to match the objects, we have utilized some mechanism, some relevance mechanism or some similarity score. And after getting these objects, we have processed or we have sent these documents for relevance ranking based on the query term proximity score. So we have two levels. So you can also, derive some sort of analogy of this model with the retrieval process, with the retrieval model also, where you can see at the first level, we are trying to retrieve the objects based on the some similarity score, some similarity mechanism. So all the data objects have been placed in the document corpus D1, D2. Then these documents have been generated with the surrogate objects O1, O2, O3 or till ON, pre-processed objects. So this user query T1, T2 is applied or matched with these objects, and to get the basic set of results, basic set of objects, we have applied some similarity measure, right? And to generate the relevance score at the matched object, because initially we will be getting around m number of objects out of n. So this relevance scoring will be done on the m number of objects, you can see. And again, these m objects will be having again these query term presence. So at this level, we are trying to basically imply the query term proximity measures to generate a proper list of arranged documents, basically based on the query terms presence within the document. So this is one typical model we have basically created, and we have derived the interface for that, and these objects are pushed into the interface, right? So in the background also, it will have these relevance measures will also have a impact. So let me briefly again share a different documents where we have proposed these measures. So let me share. So yes, yes. So this is this particular text is basically a part of research paper. So in this, let's understand. Okay. So I hope it is visible. So you can read the text also. So to understand the importance of term proximity measure, query term proximity measures. So if in the matched document set, we have two documents, D1 and D2, which are basically derived for the user query, human-computer interactions. So you can see D1 document is having all the text. So there are various text or various keywords between these three terms, human-computer interactions. So dotted objects shows that there are other words or text available within these terms. And there is this second document which says, or which is having occurrences of these three terms in one single position, right? So this is very intuitive that, okay, D1, D2 should be appearing in the higher order of the relevance. It should be appearing in the top 3 or top 2, top 3, top 1, something like that, right? So the result object D2 is promoted. That's what the effect should be, right? So here you can see D2 should be promoted due to the inherent proximity of user query term. That is the basic fundamental nature we are trying to build using the query term proximity measures, which are of type PR, type of relevance measures. So typically, if we see, the proposed measures are discussed in the documents. For example, D1 document is having these different keywords like W1, W2, W1 again. So you can have these sort of arrangements within the documents of text words or text keywords. So if you could read the definition of span measure, which is the first type of PR based measures. So I hope you can read it. The span of a user query term is defined as the length of the shortest document section covering all the query terms within the document, right? So I hope you can see. So including the occurrences that are repeated. So it says, so for any user query, like if you have query W1 and W2, so for example, the given document D and user query W1 and W2, So if in the user query these two words are appearing, W1, W2, the computed span value is 7, right? So you can see W1 is appearing here, W1, W2, that is the minimum thing. Then we have W1 here, then again W2 here. So this will cover this portion of basically it will consider these length of strings, that these length of text subpart as a span. Similarly, if you see the min cover, so min cover is again another formulation, another measure which we have proposed. It is the length of shortest document section. It is saying it is the length of shortest document section that includes at least one query term in the document, right? It is described as a min cover. So for the same document, if you see for this other query called QW1, W2, W4, the computed min cover is 7, right? So similarly, you can have min pair distance. So we have proposed 6 different measures. So this is just to understand that we can always have a new measure to understand or to compute the PR type of relevance measures, right? So let's go back to the class notes again. I hope it is still open. Yes. Okay. So this is one typical conceptual model which we have proposed by utilizing AR and PR both for relevance estimation. So during this ranking step within the retrieval model, we have utilized AR and PR based relevance estimation measures, right? So that's what we have covered already. Now, if we go to the second second dimension of relevance, which we are seeing as a explicit nature of relevance. So here you can say most of the existing approaches which are utilizing or having this nature of relevance estimation, they are mainly utilizing the direct user feedback. That's what it is means also. Whenever we talk about explicit relevance estimation for ranking process, you should be having some mechanism to basically either to label the user data or results, or to bookmark the search results, or to review, or to access. So these are the fundamental ways of doing, which we are also doing in the different platforms where search is available as a process or maybe as a system. So you should always have some mechanism to directly capture these feedbacks, right? So, or you can provide always a feature to directly operate on. Naturally, within the system, whatever operations or actions user will be performing on the interface in the background or in the algorithmic level, you should have these two schemes to take care about these explicit relevance measures. You should have a algorithm or a small approach or a small model to take care of these feedbacks in the form of rewards and penalty to the results. So whenever user is applying a positive or negative feedback on a search results during his feedback process, during his interaction process, in the background, in the backdrop, you should always have a mechanism to do or to perform these two tasks. First is you should do a mechanism to award the result, right? You should have a strategy to penalize the result, right? So suppose user is having a mechanism, user is providing some positive feedback to one result and negative to the second result. You should have an internal mechanism to basically incorporate these positive, negative feedbacks into the background system, right? So you can always have this scheme to award, reward, or promote, and similarly you have to have an approach to demote. So in a very limited system, we are having these two strategies, promotion and demotion, at the same time. Most of the system are having only award mechanism, so they are having some approach, some algorithm to award how to promote certain results. So whenever a user is having some interaction with a particular result object, like we must have some experience in this Amazon on basically recommender based systems. There, if you explore some object, they will start promoting the other similar results. But if you are not having interest on some set of articles, they immediately not demote it, right? So in very limited set of systems, they are having both strategies for both operations, promotion and demotion both. Because demotion is basically it is considered as a negative process, negative aspect of systems. So that's why people are not having this strategy into their systems during their relevance estimation steps, right? So typically you must have at least award mechanism. Whenever we observe that user has interacted with the system, you need to increase their relevance score, right? So this explicit relevance is always additional. It is additional to implicit, right? So if you are planning to have these two relevance measure, implicit and explicit, in the implicit you can have basic approach like maybe TF-IDF based system. Addition to that, you can have TF-IDF score plus you can have a relevance score for the positively feedback results. So you can have this weighted score of implicit and then explicit. So whenever we are planning to have these two, it should be always in the additive terms. It should be like implicit plus explicit base and some weight associated to each of them, right? So as user is providing some feedback to certain results or certain object, you should always increase this implicit score of that objects. And after this result will automatically appears in the top 10 or top 5 results among that, right? Something like that. So this is about explicit. So explicit says you should have a strategy to promote and to demote both. Whenever you observe that user is interacting, user is basically having some faith, having some importance on some result, right? That's what the explicit relevance measures. It is again a wide area to work upon, because explicit relevance is the area which captures the most of the modern information systems, right? Because it is assuming the user's presence, user interactions. It captures all the possible imagination of user on the search results, right? And most of the recommended systems are based on the capability of this explicit relevance measures. They are trying to capture the users interaction on the results, users features, profile feature, users profile informations. They are utilizing the product profiling informations, right? And their correlations. So most of the recommended systems are built upon these kind of relevance measures, right? And based on the schemes they are awarding for, they are having for award and reward, right? Now, moving from this, if you go to the last type of relevance measures, which is called pseudo relevance. So pseudo relevance is again, it is third and the least explored area for the search system relevance estimation. So if you typically see the process how pseudo relevance is estimated, so you can see the query is posted, and after getting the results D1 to D something that there is naturally these results will be sent to the users, and user will be conducting some sort of feedbacks, which is called explicit. In the rightmost area, you can see user judgment documents, relevance feedback, and concurrently in the background, actually system is basically estimating the documents or the results which are appearing in the first pages or maybe top 10 documents, you can say. And these top 10 documents or results has been utilized to generate some sort of relevance estimation, some sort of users relevance. And these 10 documents or relevance scores will be sent to again the feedback block. So you can see there is a feedback block is placed, and in this feedback block we are getting two inputs, pseudo feedback and relevance feedback. And these two feedbacks will be utilized to generate the new set of results for the new query, right? So whenever a new query will be posted by users, these two feedbacks will be utilized either to promote a certain document or to fetch the new set of results, something like that, right? So whenever we are talking about this retrieval model within the relevance, within this ranking block, we will have this feedback element, right? So in the modern system, modern search system and modern information retrieval system, this feedback block is used to rank as well as to match both, right? Because we are assuming that user query and user feedback both can serve two purpose. First, it is to serve to the matching process as well as to serve the ranking process, right? And these two aspects are altogether different, right? So you can maintain the list, maintain the user feedback, you can maintain the pseudo feedback, and typically in the different notions, by using the different measures, you can have some way to perform match by utilizing these feedback and user query, some way to perform relevance estimation of the retrieved results, right? So feedback is something which most of the systems, most of the modern information search systems are having now. So if you draw the modern information system block diagram, you should have a repository to store the user feedback, right? Like in the traditional block diagram which we are using from the class lecture 3 or lecture 4, we have not placed any storage entity into the block diagram. But in the modern information retrieval, they are having this additional storage entity to maintain the user's feedback, right? So, and it has become a essential mandatory component of the information system, right? So that's it for the today's class. So partially we have touched upon these three types of relevance mechanisms or relevance dimensions. If you are having a research interest, you can always explore to the literature. You will find a lot of interesting papers. So typically if you search into the any scholarly search platform like semantic search or Google Scholar, you can directly search for articles like concept of relevance, relevance dimensions, something like that. So there are very good papers available to understand this philosophy, because as far as computer science is student, it is one of the widely, area, or you can say the portion which is affecting most of the system, because getting the relevant